Welcome to my presentation, Coastal Management, Supporting Tools and Methods. My name is Johanna Schumacher and I'm a scientist in the Coastal and Marine Management Group at the Leibniz-Institute for Baltic Sea Research in Warnemünde, Germany, and also at the Marine Research Institute at Klaipeda University in Lithuania. To give you an overview about this lecture, I will start with the background about decision support tools and their need in coastal policy implementation, and provide you some examples of different decision support tool types. And then I will focus on tools that are used to support coastal and marine management and show how they can be applied in the systems approach. And finally, I will summarize the main points, focusing on the strengths and weaknesses. To give you some background, decision support tools are considered to be beneficial for supporting coastal and marine policy implementation. And hereby they fulfill different purposes. They can incorporate scientific information into decision making, and they also ensure comparability between different systems, for example, the North and the Baltic Sea. They can facilitate participatory processes, and they also serve as knowledge base as they collect a lot of information and integrate it in order to communicate these information. But what do I actually mean when I talk about decision support tools? In general, it can be defined as any computer-based tool that condenses information in order to support decision-making. And as you will see in the following examples, this covers a variety of different tool types, and they also address different target groups. So the first example that I would like to introduce is the Baltic Health Index. This is a holistic indicator-based tool that assesses the health of the Baltic Sea and its subsystems. It focuses on the benefits that oceans provide to humans. So it's not only an environmental assessment, but it looks at different goals, for example, tourism and recreation, carbon storage, and fisheries. And with this, it integrates a large amount of environmental, but also socioeconomic data. And the tool is used to monitor the current state of the Baltic Sea and its subsystems, but also the progress towards these goals. For each goal, a management target is defined, which is represented by the score 100, and you then assess how far you are away from this target. Benefits of this tool are that it supports the fulfillment of the Sustainable Development Goals, so it has a direct policy connection. It helps to identify management priorities for the goals where you are still far away from the target, and it enables comparison. Weaknesses are that for some of these goals, there's a lack of data and also missing reference values. The second tool is Symphony. Symphony is a mapping tool for ecosystem-based marine spatial planning. And it estimates and maps the cumulative impacts of human pressures on ecosystem components. Human pressures can, for example, be fish catches or also different levels of pollution, as you can see in the picture. And the ecosystem components are then, for example, spawning habitats or also mussel reefs. And the assessment is based on a sensitivity matrix. So this tool informs about baseline conditions in an area, but it can also be used to show potential effects of different planning options and also climate change effects on the cumulative impacts in different areas. The strength of this tool is that it is applied in MSP, so Marine Spatial Planning implementation in Sweden, and it is not only restricted to applications in Sweden, but also transferable to other areas. So it directly supports the implementation of MSP. Weaknesses are that it is subject to simplifications and uncertainties, which is a common problem of many decision support tools. And it is also quite costly since it's not open source software. Also, models can be considered decision support tools. And one example that I would like to show here is the Baltic Sea long-term large-scale eutrophication model, or in short, BALTSEM. BALTSEM is a coupled physical biogeochemical model, and it divides the Baltic Sea into 13 connected sub-basins, as you can see in the figure. The tool has a high vertical resolution, and it is used to determine the maximum allowable nutrient inputs and country allocations for Baltic Sea, for the Baltic Sea Action Plan. So how much each country, how much nutrients they can emit so that the eutrophication targets are still fulfilled. Benefits of this tool are that it allows fast simulations, and it is integrated into the decision support system NEST. So it is integrated with other decision support tools, and it supports also the implementation of the Marine Framework Directive in the Baltic Sea. Weaknesses are that it has a very low resolution, and it is problematic in areas with strong gradients, like salinity gradients, which are common for the Western Baltic Sea. And because of this, it does not really allow applications to support integrated coastal zone management, which usually take place on much more local or regional scale. So another model tool is ERGOM, and ERGOM is a 3D ecosystem model of the Baltic Sea. And in comparison to BALTSEM, it has a much higher and flexible resolution, and it is therefore suitable for a wide range of applications. And it also has a long-term stability. And this brings the benefits that it enables tailor-made applications. For example, it was used to determine water quality targets for the Marine Strategy Framework Directive, but it was also used for ICZM case studies, as you will see later in this presentation. But it also has some weaknesses. It has a very high computational effort when you use it for large-scale modeling, and it has a restricted predictive capacity because of the limited number of variables that are included in the tool. Also, within integrated coastal zone management, supporting tools are quite important. And as I introduced in previous lectures, a major weakness of integrated coastal zone management was the lacking guidance and vague requirements, which hampered practical applications. And the systems approach framework, which is illustrated in this figure, it provides a systematic and stepwise approach with concrete actions to address coastal issues. And when this was developed, also supporting tools were developed that can be used throughout the different steps. And in the second part of this presentation, I will introduce some of these tools and show how they are applied within the systems approach. The first tool that I'm introducing is the DAPSI worm framework, or often better known as DPSIR framework. It generates a common understanding of an issue and its causes and effects. And as such, it's used in the issue identification step of the sub-framework. So the letters stand for drivers, activities, pressures, state changes, impacts on welfare, and responses as measures. And I will use the example of coastal eutrophication to briefly show you what the different components stand for. So drivers are usually basic human needs, such as the need for food, energy, or shelter. And these drivers then lead to human activities, such as agriculture and sewage treatment, which leads to discharges of sewage into water bodies. The activities then have pressures on the natural system. In our case of coastal eutrophication, this is then the nitrogen and phosphorus enrichment by input of fertilizers and sewage. And these pressures cause changes in the natural system. So this can be the high chlorophyll A concentrations and low water transparencies, but also hypoxia, which is the lack of oxygen. And in response to these changes in the natural system, this also causes impacts on the human system, so on welfare. This could, for example, be fish kills, which are nuisances for beach visitors, but they can also cause economic loss for fishermen, also beach closures or the failure to meet policy requirements could be an impact on welfare. And these then require a response, for example, an improved river basin management or internal measures such as mussel mitigation farms, which could be established. When you use this tool within the systems approach, you usually need several cycles, as the responses then lead to new activities, pressures, and also direct impacts. So as I said, it's used to generate a common understanding and usually in the first step of the systems approach. Another tool for the issue identification is the CATWOE analysis. And CATWOE stands for Customers, Actors, Transformational Process, Worldview, Owners, and Environment. And this tool is used to gain a broad understanding of an issue and also to identify the main stakeholders that need to be involved in the process. So when you apply it, you usually start with the transformation and the worldview. The transformation is the conversion of inputs to outputs. So what this means is, in our case, the increased nutrient retention and decreased resource expansion by a mussel farm that we could implement. And the worldview is the meaningful context of the transformation. So this could be, in our case, that fighting eutrophication is a global problem of many coastal waters and requires actions. And after you filled these two components, you fill all the other ones. So customers, these are the victims or the beneficiaries of the transformation. So in our case, it could be coastal communities, tourism, or the government who would benefit from better water quality and higher transparencies. And victims could be, for example, fishermen who might be affected by changes in the fish species composition. Actors are those who do the transformation. So in our case, it could be environmental agencies responsible for water quality improvement, but also investors who are interested in mussel cultivation. The owners are those who stop or who can stop the transformation. This could be local authorities, but also fishermen or the public if it comes to strong oppositions. And the environment, this is the unchangeable elements outside of the system. So this could be an attraction of non-indigenous species or also heat waves. In the systems approach framework, this is usually applied in this issue identification. Another tool is the stakeholder preference and planning tool. And this tool is used to develop a future development vision by choosing different success criteria. And these are criteria that should be fulfilled in the end of the implementation of a measure. So in our stakeholder group, we discussed different mussel farm scenarios, and the stakeholders said that minimal spatial conflicts, high public acceptance, enhancing quality of life, and being sustainable are the major success criteria for a measure that should be considered. So with this tool, you weigh the different criteria in a moderated stakeholder discussion. And this enables focused and guided discussions so that all opinions are heard and not only the ones of the most noisiest stakeholders in the room. And the tool can then be applied to assess how different measures are suitable to fulfill the success criteria. And in the end, as the overall result, it evaluates measures based on stakeholder preferences. Another tool is the indicator-based sustainability assessment tool. It assesses impacts of measures on environmental, social, and economic components. And this is done in a sustainability assessment using the 3 main pillars of sustainability. And each pillar is reflected by a number of indicators. And as you can see on the right side of the figure, each indicator is then scored on a scale from -3 to 3, showing whether the measure that is implemented had positive or negative impacts on the indicator. And the 4th category that is assessed is called governance, and this assesses the process. So whether the principles of ICZM were actually implemented in the case study. Here you see the results of 2 applications of the tool for Geltinger Birk and Timmendorf. And you can see that for the coastal realignment and lagoon restoration case study, this measure had quite positive and considerable effects on environmental quality and also social well-being, whereas the integrated flood defense did not have strong effects on the state of sustainability. But with the governance or the process indicators, it shows that the principles of ICZM were very well reflected, and therefore it can be considered as a best practice case study. So with this, the tool assesses and illustrates strengths and weaknesses of measures or ICZM case studies. And the last tool for the systems approach framework that I like to introduce is the Marine Ecosystem Service Assessment Tool, or short MESAT, and it assesses the relative changes in the ecosystem service provision. This can be used for assessing changes over time. So you would compare the current provision of ecosystem service with the point in time in the past or in the future. And also impacts of different management options on the ecosystem service provision can be assessed. So this can be done in a data-based approach where you use literature or modeling results to fulfill the different indicators. Or you can also use it with expert opinions who score the different measures. Here you see an overview about the tools and in which steps of the systems approach framework they are applied. As you can see, the DPSIR and CATWOE are usually just applied in the issue identification, but the other 3 tools can be applied throughout the process as guiding tools as well. So, for example, with the Marine Ecosystem Service Assessment tool, you can apply it in the issue identification to assess what are the relevant ecosystem services in your study area and which ones might be affected. In the system assessment, where you simulate effects of different management options or measures, the tool can be reapplied to see what are the impacts of these measures on the provision of the ecosystem services. And finally, in the evaluation, you can use the tool again and see how the ecosystem service provision has changed over time, so before and after the implementation of the measure. So you see that there are particular tools for most of the 6 sub-steps, but for the systems approach for the system formulation, there is none indicated, and this is because in this step you simulate different scenarios, and for this tailor-made tools and especially models are needed. So in our case study, as an example, we used the ERGOM model, which I introduced earlier, and it was and the 3D ecosystem service model was applied together with an expanded mussel module to assess effects of a beach mussel farm on water transparency, as one example. And the tool has a very high spatial and temporal resolution, and this is needed to reflect processes sufficiently. So with this example, I just want to briefly illustrate that here you really need tailor-made approaches that are locally specific. So let's summarize the main points of this lecture. You saw that numerous tools are available to support coastal and marine management. And this covers a variety of tools like GIS-based planning tools, indicator-based assessments, but also models or tools that are used directly for stakeholder involvement. They address different components. For example, some are used for environmental assessments only, while others integrate more holistic assessments. And they address different target groups. Some are made particular to support environmental managers, while others are more addressed to stakeholders and support participatory processes or provide information to the public. On a general level, we can say that strength of decision support tools are that they can ensure comparability, they support the science policy transfer, they serve as knowledge base by integrating a lot of data in a holistic way. They support coastal and marine management and policy implementation, and they can simplify and communicate complex phenomena. General weaknesses are that comparability is often also lacking because different approaches are used. Decision support tools are often subject to simplifications or oversimplifications, and they inherit a lot of uncertainties. And applications for some of the tools, especially models, require a lot of expertise and often also are quite time-consuming. And the lack of funding is a major problem. And this also leads to the effect that even though many decision support tools exist, they are often limited, the applications are often limited to the project duration, so the projects in which they developed. And the main weakness why decision support tools might not be used is the lack of awareness among the target groups. ICZM addresses a broad range of issues on a local or regional level. And therefore, this requires flexible tools that can be adjusted to local or regional specificities. So also tools that support participatory processes are needed, in particular to support integrated coastal zone management. And therefore, I would like to focus on the strengths and weaknesses of the supporting tools for this systems approach framework here separately. Strength of the tools that I introduced are that they are often user-friendly and they are easily applicable by non-experts. They are usually not case-specific, but can be easily transferred to various ICZM case studies, and most of them support participatory processes. Weaknesses are that they are not directly integrated into policy, so they are aimed to support integrated coastal zone management, but there are no specific requirements to apply these tools. They lack additional benefits, so they might not be so attractive for coastal municipalities to be applied because of this, and most of the tools are affected by a high level of subjectivity. So therefore, there's a limited comparability. But for integrated coastal zone management, we need tools that can be applied on a local level, and therefore comparability might not be so important as in other tools that are applied on a Baltic Sea-wide level. And if you like to learn more about the tools that are available in the Baltic Sea region for supporting coastal and marine management, you can have a look at the DST database. And to get to know the supporting tools for the systems approach framework, you find detailed information about these tools and also how they are applied in the systems approach in the SAF handbook. And with this, I like to thank you for your attention.